Okay for the 3 points? Okay for the 4 points? Oh, let's go. So maybe for the 3 points, you can propose this kind of thing, or you can propose also this kind of things. Okay, and maybe this thing, I don't know, I don't know. And maybe I don't have idea for the, someone have another idea. Or maybe this. Yes. Okay, so this is for the 3 points, and for the 4 points, the same kind of things. Maybe someone has proposed this. Maybe it can be a good idea. Someone, this also. Okay. I have no more place. Well, I propose. After this, maybe this. Okay. So there are several solutions, several ways to see these problems. So when I put points on the corner, my idea is to have to put the points on the bounds, of course, to put the points on the bounds. So okay, there are some problems with this kind of techniques, but it's a good solution to put the points on the bound. However, here I have forgotten all these zones, so maybe it's better to make this. Puff, puff, puff. However, of course, I have only 3 points, so I missed something. So for the 3 points, this can be more interesting because we form a kind of combination between x1 and x2. Okay. There are other problems with this kind of design that I will explain. For the 4 points, here you see I put the points inside the domain. So maybe my idea, with respect to this solution, I have another idea. With this solution, I put the points on the corners, and so I want to have the information at the border of the domains. And okay, and here I want to have the solutions inside the domain. In fact, when I put this kind of configuration, what I want to do is to minimize a kind of distance, a distance between any points of the domain and the point of the design. I will explain this later. It will be easier with the figure in my slides. However, with this, I have a little issue. You see, I put 2 points at the same level of x1 here, and the 2 points at the same level of x1 here. This is x1, and this is x2. And same, I put 2 points at the same level here, and 2 points at the same level here. It means something for me. It means that, imagine that if x1 or x2 are not influenced, I lose some information. Because if x2 is not influenced, okay, so only x1 is influenced. In fact, this and this will be the same. I have the same results if x2 is not influential in my system G. G depends only on x1, so here and here I have the same values. And here I have the same values. So I have lose, in fact, 2 points. At the beginning, I didn't know that x2 is not influential. But if x2 is not influential, I lose 2 points on 4 points. So I lose a huge amount of potential information. With this kind of configuration, I avoid this effect because you see that the point does not collapse on the axis. this is the term, collapse. Okay, so if x2 is no influential, I have 4 information because the projections are not the same. Is it clear, this kind of concept? So it's better to do this. I will explain after the techniques to have this kind of things instead of this kind of things. If someone has another solutions that he thinks is very, very interesting, and he can come if he wants. If someone has a better solution that I propose, maybe, I don't know. Nobody? Okay, nobody. So this kind of problem, in fact, are difficult to solve. And so in my lecture today, this morning, I will try to define a few mathematical criteria to solve, and after some algorithm which allows to optimize this mathematical criterion.